Hey, hi everyone, this is Vishal. Welcome to our channel Bug Free. So today's topic is hashing and partition keys. Okay, so let's get started. So as you also already know, and you must have studied and known in databases as well as data structures as well, that hashing is a very important topic, right? So let's understand what hashing is. Okay, so we'll simply take a list of numbers here. Okay, so say the list of array or list, you can say. Let's have the numbers, any random numbers. 1, 2, 4, 7, 9, 6, 0, 11, 33. So we have a array of integers here, right? Now what we need to do is, we need to search for a number, right? What we'll do here is that, if I go for a normal general search, what we'll do, we'll simply go here, we search the first number, right? Say we want to search the number 1, num equals to 1. Then for the first instance, it got searched within the first element only. What if the number was, instead of 1, it was 33? Then we would have to traverse throughout the list and get it at the end. The other way to search are binary search. What we will do, we'll simply divide into half, like a tree, then half, and it will continue. The search will continue where this is the parent node and others are child nodes. Where the left hand side, this part is, say this is denoted by x, this is y, and this is z, right? So in this way, what happens is, x is always less than equal to y and z is always greater than y. We can take this as a concept, right? So in this, what is the overall search criteria? It is normally in the form of n log n, right? This is the overall time complexity for this. Now, how to even do it better? Let's go for that. That's where the concept of hashing comes into picture, right? So what hashing is? What it does is that, every time when we are trying to search and we are storing data, right? We, instead of storing in this way, we'll store in the base of some hash key. How will we get the hash key? That will be a function based on which we'll calculate the value of this particular item, right? Or the element. Suppose this is a list here. The hash function can be anything. For example, let's say this is a list of elements, right? Like, let's the name of the element is array, ARR, right? Now what will happen is that we will have a function of f of x equals to, we can say, let's say for the example of where y remainder 5. We can take a concept like this. This is a method. This is a modulus function. What it will do, it will give us the remainder when y is divided by 5. So what the answers will be in the form of 0, 1, 2, 3 and 4, right? Now what happens here is that, all these values, these 4, 5 values are there, right? These will become the alternate values of these items, right? What can we do here? So let's say we are arranging it in this form. Say 1, when the number was 1, num equals to 1. So it is passed in the value of x here. Now the y will be, here the, instead of y, it will be x only. F of x is there, right? That's right. So where the x value is 1, right? Instead of n, num, it will be x. X value is 1. The value will be 1 modulus 5. It will be 1, right? So here, instead of 1, the value it will be coming as 1. So its key is 1, right? Now let's go to the second number, 2. X equals to 2. Then the value will be getting as 2 remainder mod 5 equals to 2, right? Now what will happen to these values? These values work as the keys, you can say, or the partition keys. These values are the partition keys here, based on which we have partitioned this array elements, right? So how are we storing it? We are storing it in this way: 0, 1, 2, 3, and 4. Okay. Now for 0, we don't have anything. Now we got this x equals to 1 for the first element. The value is 1. So for this, we'll get the value as 1 here. Right? So the second element, when we went for the second element, the value came as 2. We stored the second element. Right? When we go to number 4, x equals to 4. Again, if you go like this, the remainder will be 4. So for 4, we got the number item 4 for the third element, right? When we go for 7, x equals to 7. Again, remainder 2. So here it will be happening as number 2. Sorry, my bad. Here it will be 7, right? Now when we go for number 9, again 9 when divided by 5 gives a remainder of 4. So it will come for the key of 4. Go for number 6. If you go for number 6, when divided by 5, it will give a remainder as 1. So we will go for number 6. Again, when we go for 0, number 5, so 0 will come here. Now when you go for number 11, it will come here, right? And when we go for number 33, it will go for 5, 6, 30 plus 3. So 3 is the remainder here. So 33 will come as here, right? So instead of arranging it in this way, we arrange it this way, right? So now you can say the searching is really simple. Now if you want to search, suppose we want to search 6, instead of going for the normal way or either way, we can simply find the value 6, apply the hash function, get the partition key. Here it is, right? In this you got the partition key, right? In this key you went here, first element, traversed here, second element, 6, right? We got it in the order of 2 here, right? The second element is there. We are getting in constant time basically. That's why it is very helpful. Now let's imagine it is 33. What will happen here? We got in order of 1, right? Isn't it better? Now there is a problem here, you know. What is the problem? The problem is of scalability problem. What is the scalability problem? Now let's imagine we get, instead of all these random numbers, we are getting say 43, 53, 58, 78, right? So all these numbers when divided by 5, right, will leave a remainder of 3, correct? So this partition key will be having a lot of numbers, right, side by side. Now again, if you have a long So in this case, a lot of numbers will be coming in for the partition key 3. And suppose this list becomes long enough, again the same issue that was coming here will happen, right? Correct, no? So in this case, what we need to do is, inside of this again we can apply the partition keys. We can find another set of hash function based on which we can divide this list into a subset of partition keys, correct? So in this way we can improve the performance. One more way is that, suppose we have binary search algorithms. There are different algorithms, right? We can apply those within this list of elements here, right? So overall, in this way we can improve the performance of the application, correct? And these are the partition keys. That's all. Thank you for now. We'll see you later.
रुको जरा सबर करो. The video is not completed yet. If you like the video, Please like, share, and subscribe.